Continuing on section 3.4, a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend, at most, $50 for this project. What are the possible number of cases the club can buy? So here, the club can spend, at most, $50. So the amount that they spend compared to $50. Could they spend all $50? Yep. Could they spend $60 or could they spend $40? Well, they only have $50, so they could spend $40, but they can't spend $60. So the amount they spend has to be less than or equal to $50. Okay, and what they're spending their money on is cases of vegetables that cost $10.68. So it's $10.68 times each case. And again, C is case of veggies is less than or equal to 50. Right now, my variable is being multiplied, so I get rid of it by dividing. Whatever I do to one side, I still do to both. Since I divided by a positive number, I bring down my inequality. And when I take 50 divided by 10.68, I get 4.68. And then some more digits there. But we can't we can't buy exactly 4.68 cases. We're going to buy whole number amounts of cases. So here, since we need less than that amount, we're going to take this down to 4. So our cases is less than or equal to 4, but the possible number of cases then we could buy is we could buy 0, we could buy 1, we could buy 2, we could buy 3, or we could buy 4. Keep in mind, I'm going to list them out here, guys, because I can't buy partial cases or negative cases. So you could put C less than or equal to 4 whole cases. Or since it's just a small amount of numbers, you can list them out. We could decide, you know what, maybe we're not going to get vegetables and get 0, 1, 2, 3, or 4, and those are our only options. Again, feel free to pause here and give this a try if you'd like. X is being multiplied by -5. We get rid of multiplication by dividing. And whatever I do to one side, I do to both. -5 divided by 5 is 1 times x is x. -10 divided by -5 is 2. Now, because I divided by a negative number here, I have to flip my inequality. So x less than 2. If I plug in 2, I get -10 equals -10, so I know my boundary point is right as far as my solution goes. Now we need to graph it and check and see if our inequality is right. Boundary point, one number on each side, and 0. Circle at 2. I'm not going to fill that in because there's not an equal to here on my inequality. We want our solution or our shading or our values to be less than 2, numbers like 1, 0, and -100. So we shade everything to the left. If we check that, if I plug in 0, for example, I get 0 is greater than -10, which is true. So our solution there is correct. Quick recap here. In the same way multiplication and division are used to solve equations, multiplication and division can be used to solve inequalities. When multiplying or dividing by a negative number, it's necessary to reverse the inequality sign. And that's all I have for section 3.3.